my lecture today. So, like I said, since I realized that they've been having a low turnout, I'm actually going to be making my video. And of course, I'm going to be sharing that with everyone. So, I want to welcome you to my lecture today. Of course, in today's lecture, I'm going to walk us through the derivative of trigonometric function. Now, in the derivative of trigonometric function, so actually, uh, we're actually I'm going to walk you through how to differentiate trigonometric function. When I talk about trigonometric functions, I'm talking about the sine, the cos, the tan, and so on, like that. So if you take a look at, if I have a sine u, okay, so, and I want to differentiate sine u, so what I'm actually going to do is I need to differentiate u part. Differentiating u part is actually that guy. And then differentiating sine u is actually cos u, okay? Now, I'm actually going to say what we have around here is fundamentals. Okay, differentiating sine u actually cos u, differentiating tan u is sec square u, and of course, differentiating sec u is actually sec u tan u, and differentiating cos u is negative sine u. Differentiating cos u is actually negative cosec square u. So differentiating cosec square u, you're actually going to have that. So you need to first like get yourself familiar with what you have here. Okay, so if I want to get started right now, if you take a look at what I have in the answer key, okay, when f of t equal to t squared sine t, differentiating that equal to that. So I'm actually going to walk you through that right now. Okay, you're going to see how that is going to be done. Now, here you're going to use a product rule. I got two functions here. One is t squared sine t. So what I'm actually going to do is I'm going to differentiate, whenever I have two different functions, okay, I'm actually going to use a product rule. Okay, so right now I'm going to write one, differentiate the other one, plus write one, differentiate the other one. So let's say I differentiate t squared now, that's going to be 2t, right? Then I'm going to write sine t. Okay, I'm going to write sine t. Okay, then I'm going to write plus. Okay, this time around, I'm not going to differentiate t squared. I'm going to write t squared. Okay, then I'm going to differentiate sine t. So differentiating sine t is actually going to give you cos t. Okay, so when you take a look at this guy, that's actually going to be a final answer. So if you want to go back to the answer key, okay, and that was why you see 2t sine t plus t squared cos t. Okay, you can see that we got the same answer here. So I think I've applied product rule here. Okay, apply product rule. So what I've just done here, when we look at the general formula for the product rule, is like I get a function of t, right, and multiply by another function of t. Okay, so if I have something like this, okay, so if I want to differentiate right now, my f of t is like a t squared, my g of t is like a sine t. So, well, if I want to differentiate this guy, so let's say I have this product now, and I want to do ddt. Okay, I want to do ddt. Okay, so do ddt with that. Okay, what I'm going to do, for differentiate f of t, which is going to be f prime of t. Okay, and I'm going to write g of t. I'm not going to do anything to g of t. Okay, now what I'm going to do right now, I'm going to say plus. Okay, don't forget the other time I differentiated f of t, but I'm not going to differentiate f of t anymore. I'm actually going to write that. Then I'm going to differentiate g of t. So this particular approach is actually the product rule. Okay, it's actually the product rule, which is exactly what I apply here. Now, you're actually going to use product rule whenever you have two functions multiplying themselves. Okay. Now, I'm going to clear my board right now. I'm actually going to go to the next question. Okay, so it's okay. Look at the next question. Okay, we're going to look at the next question now. Question 42. Okay, it's actually f of s equals sin s over s to the power 3. Now, whenever you have stuff like that, I can actually say that, okay, f of s equal to this, I can actually just call that a u and call the other one v. So situation where I got a different function, a function divided by another function, I'm actually going to use a quotient rule. What I actually want to do is I want to figure how f prime, the derivative of f of x, right? So the derivative of f of x, I'm actually going to write whatever function I have in the denominator. Okay, that's a v, right? Then I'm actually going to differentiate the numerator now. Okay, that will be du dx, right? Okay, minus, okay, then the u, what I have in the numerator. Okay, then the v dx. Okay, the v dx. Okay, and all of these divided by v squared. Okay, so this is a quotient rule. So if I want to apply this guy now, okay, so what I'm going to do, I'm going to write v first. Okay, so let me borrow a space here. Give me a second. Okay, I'm going to borrow a space here for this. So my f prime of s right now. Okay, my f prime, okay, of s. So my f prime of s right now is actually what is my v? X raised to the power 3. Okay, and let me write that so that's gonna make sense. Okay, x raised to the power 3. Like I said, you're gonna write v first without doing anything. Then the UDS. The UDS means I want to differentiate sin s. So differentiating sin s is cos x according to the law. Okay. Okay. Minus. Okay. So what is u? So u is going to be sin s. Okay. Then differentiating v, x raised to the power 3. That will be 3s squared, right? That will be 3s squared, right? Now everything divided by v squared. So which means I'm actually going to have x raised to the power 3, okay, or squared, okay? So all you need to do is just to simplify. So if I want to simplify right now, okay, I got x raised to the power 3 here, right? I got x raised to the power 2 here, right? I can actually write s squared, okay, that is common to both sides, into s cos x, okay? You're going to open your parentheses, okay, s cos x, okay, minus, okay, 3, okay, so minus 3 sin s, okay, minus 3 sin s, take a look at what I have right now. Okay, I'm going to close the bracket. Then I'm going to divide by x raised to, that will be x raised to the power 6. Okay, so this is going to reduce that, okay, to x raised to the power 4. So if I want to write the final answer now, okay, so what I'm actually trying to tell the world is after simplifying that, okay, after simplifying that, I'm actually going to write, it's going to be x, okay, cos, okay, s cos x, okay, minus 3 sin s, okay, minus 3 sin s, okay, and of course, I think I've canceled the, okay, s squared here, I only have this, then divided by x raised to the power 4, okay, so this is actually going to be the final answer. So if you go to the answer key, number 42, okay, if you go to answer key number 42, okay, you can see s cos x minus 3 sin s divided by x raised to the power 4. Okay, that is exactly what we got. Okay, so so far so good, right? If I actually go to the next question, they said they're gonna be super easy because when I have, if a function is equal to the sum of another two functions, that would be super cool to do. So what I'm gonna do here, differentiating this one, it's gonna be -1, right? So differentiating tan x, okay, you're actually gonna use a general rule. So that's gonna be s squared s. Okay, that's gonna be s squared s. Okay, and I can write this as I can write this as s squared s, okay, minus 1. Like I said, you're actually going to use a general rule. If you come back to general rule, okay, if I have tan s, okay, tan s is tan u is s squared u, okay, and also why you see you're writing s squared here, okay. So if you check 43 right now, the answer key for 43, right? Okay, give me 1 second. I'm actually gonna check 43 now. Okay, let me see the answer key for 43. Okay, you can see it here. That was why you get -1 plus s squared x. So which is the same answer that I got. Okay, so let me do first another one that may look kind of complicated. Okay, now how do you handle stuff like this? Okay, whether you want to attend this or you want to attend that, you're actually going to use a product. Okay, so you're going to use a product rule here, you're going to use a product rule here, you're going to use a product rule here and here before you add them up. You're also going to use a product rule here and product rule here because you can for split that into 2, differentiating that with the using the idea of a product rule before we had them all. Okay, now if I work on this guy now, so if I want to go by the product rule, okay, don't forget, now my product rule is if this is f, okay, and this is g, okay, don't forget what the product rule says. I'm actually going to say, okay, f prime, differentiating f, don't differentiate g, plus, okay, then write f, okay, don't differentiate f, but you know what differentiates g, okay? Now, when you take a look at what I have here, f prime n, differentiating F, that's going to be 2x, right? Okay, so don't differentiate G. I'm actually going to write tan x. Okay, I'm actually going to write tan x. Okay, then plus F. I'm going to write S squared. Then differentiating G. When I differentiate tan x, it's going to be sec square x. Okay, and whenever you are done, differentiating tan x, I move from the standard rule. Or what I'm going to do is to factorize, what is common now. Okay, so can bring out x into 2 tan x, okay, into 2 tan x, okay, plus x, okay, sec square x, okay, sec squared, sec square x, okay, you see that? And that is how, let me write it to you very well. Okay, give me 1 second. I think I'm going to rewrite the square so that you're going to. So that is how to go about. So you're going to do the same thing here. You see, using the same product rule. Okay, so sin s. Okay, differentiating cos s is negative sin x. Okay, differentiating cos s is negative sin s. Okay, plus. Don't forget here too, this is f. Okay, this is g. Okay, so f prime. Okay, so let me quickly do this. So if f is sin s, right? I'm actually going to differentiate that. That's going to be cos x. Okay, then I'm going to write g. The g is cos x, right? Okay, okay, then plus, what do I want to do now? I'm actually going to write f. F is sin x, right? F is sin x, right? Take a look at that. Then differentiating cos x. That is negative sin x, right? It's going to be negative sin x. Okay? So all what you're going to do now is just to simplify. So when I use this to multiply that, I'm actually going to have cos square x. Okay? Then minus sin square x. Okay? So take a look at that. So when you take a look at number 52, okay, you can see cos square x minus sin square x. So if you follow every other one, okay, like I said, yeah, I said you're going to use a product rule, right? Okay, which is what is applicable here. For this one, you're also going to use a product rule, right? Which is what is applicable here. Then you're going to add them up, you're going to simplify, that will give you this. Now, I'm going to come to this guy now. Okay, you're actually going to cut that into 2. Cutting that into 2. Don't forget F and G. You remember F and G. Okay, F and G, because they must, we got to functions multiplying. Okay, so here now, if I do F prime and I write G, when I different, I can actually do F prime G plus F by F G prime. So if I differentiate 5 theta, that's going to be 5, right? And I'm going to write sec theta. Okay, now I'm gonna do the same. I'm gonna write the 5, 5 theta. I'm gonna differentiate sec theta. Sec theta is gonna be sec theta tan theta, according to the rule. Then I'm gonna come in. I'm gonna do the same. Differentiating theta 1, right g tan theta plus, okay, and then f theta. Then differentiating that, I'm gonna have this. By the time I simplify, that's actually gonna be that. Okay. is super cool. Okay, now I want to come to chain rule now. Okay, now before coming to chain rule, I want to believe you understand how we differentiate trigonometric function. Okay, now since you understand trigonometric function, I actually want to walk you through chain rule. Okay, and I want to welcome you to chain rule. If you want to understand chain rule,